Okay. Okay, we'll just start in 30 seconds. Hey, my name is Damu Venkatesan. I head the healthcare virtual chapter for PASS, and thank you for joining today's session. And let's go through some of the routine, slides. This is the February meeting. Okay, coming up in April is the PASS Business Analytics Conference. You can register to today. Actually, if you use the SQL, if you use the BAVCHE code, you can save $150 off of the registration. And there's like a couple of sessions exclusively on the healthcare data analytics, and also in general you'll see a lot of analytics talks in that experts around the world presenting in the BA conference. Be a really good one if you're into analytics and if you do a lot of analysis. That's in Santa Clara, California. That's in April 20th through 22nd, 3 days. And the people in Europe can attend the SQL Rally. It's like a mini conference, SQL Server conference. It's in Copenhagen between March 2nd and 4th. And there, if you use the PASS chapter S5, you can save 5% of the registration. These are the different virtual chapters that are available in SQL Server, PASS community, like big data and business intelligence, and healthcare is of course ours, and data architecture. And then there's a new one that is coming up is data science. So anybody interested can join the virtual chapters through your PASS account. And there's SQL Saturdays. That's like a free day of training. Happens on Saturdays around the world. And these are the next, in the couple of months, what's coming up is, some in Cleveland, Tampa, Silicon Valley, and, Australia, Budapest, everywhere. So if you're near that area, please register at SQLSaturday.com, and you will be able to attend it for free. So it's like an entire day of different topics on SQL Server. And of course, if you want to volunteer something for the PASS community, for the SQL Server user groups, you can attend, you can register yourself at volunteer.sqlpass.org or through your MyPass profile in the SQL Pass website. How do you, connect with us? For the healthcare virtual chapter, we have a website, of course, healthcare.sqlpass.org. And our Twitter account is healthcare SQL VC. So if you could follow us on Twitter, definitely, we make some announcements there regarding our meetings and, upcoming events. We have a LinkedIn group as well called PASS Healthcare VC. So if you join that group, you can get some updates through that. And of course, the chapter leaders for that is me, Damu Venkatesan, and Neil Waterstreet. And you can reach us at healthcare.sqlpass.org, email address. And so let's move on to today's presentation. Today, David Moutray, he's a DBA and ETL developer at Aller Wellbeing, a healthcare company. And he's going to talk about data quality, how you can improve your performance, the application software performance, and increase the profits in your business by having a good data. So that's the main thing. And he is been in the industry for a long time, and he seen a variety of situations, and he's going to talk to us today. And you can reach him at, if you have any questions later on, you can either email us or you can email him at sql.david.moutray@gmail.com. And you can follow him on Twitter at dmoutray. So now let's give control to David. David, are you ready?
I am ready.
Okay. All right, you take it away. And if you have anybody have any questions, you can put it in the question panel, and then we'll ask David. When it's appropriate, we can interrupt him if we need to. If you have any questions, then otherwise we can have the question and answers at the end. Thank you, David. Take it away.
Thank you, Don. This is me. There's my email address and Twitter handle. If you have a question, contact me. I will get back to you. So today I want to talk about data quality. And I would like for my slide. Okay. There we go. So I went for a job interview some years ago. The very first question the interviewer asked me was, what is the greatest weakness of SQL Server? My response at the time was something like, well, I really don't know. And the gentleman was far too nice to say, well, we're done here. But sadly, we were. That has always bothered me. And so I've thought about that question a lot. I think it's an excellent question. And so the answer that I've come up with, as I've thought about it over the years, is I think the greatest weakness of SQL Server is that application developers don't really get it. They don't understand it. They don't understand the purpose of it. What I mean by that is I think for all of our business applications, the heart of the matter really wraps around the data. Application developers are focused on creating the functionality for their applications, whether it's a web application or a .NET application of some kind. They're focused on creating that nice website, that nice user experience. They're not so much thinking about the data that their applications collect. But other than the immediate user who is on the website, all of the other people with an interest in that application are really interested in the data. You have database administrators who are focused on ensuring that the data is always available. You have your business intelligence people that are trying to generate reports for everybody else. And then the business users who may use some of the application functionality, but mainly they're consuming the data. To take a step back, if you go back 50, 60 years in software engineering, you had a lot of very, very smart people writing applications for mainframes. And the business executives would look at these software applications and they would say, this is great, but we have this payroll application over here, we have this order taking application over here, and then we have this sales application over here. None of them talk to each other. So that was the whole purpose for which relational databases were designed. But it has taken so long, decades, to properly implement relational databases that we've sort of lost track of that. We've been so focused on the trees, we've lost sight of the forest. To illustrate something of what I'm talking about, I'd like to share with you a user story that I heard on a presentation by Thomas Redman, which, by the way, if you ever have the opportunity to hear Thomas Redman speak, they call him Dr. Data, take it. He's a terrific speaker. His presentations aren't technical at all. They're geared towards business users, but they're profound. So, meet Julie. I don't know who this young lady is other than I typed "Meet Julie" into Google, and her picture came up. But in this story, Julie is a sales representative for a national retail company. She lives and works in Akron, Ohio, and recently Julie won a national sales competition. And the prize for winning this competition is an all-expense-paid trip to New York City for the annual sales conference. So she and her husband go to New York. It's their first time visiting New York together. And one of the things they decide to do is, of course, take in a Broadway show. So they attend the show. It's terrific. They love it. They're having a great time. They walk out of the theater after the show, and Julie gets a text message on her phone. She looks down. She sees, oh, the restaurant around the corner, a block and a half away from where you are right now, is offering half-price mojitos. Just present this digital coupon. And I thought when I first heard this story, what a terrific product or service. Imagine how many times you could sell that data. You can sell it to Julie, of course. That's a great service. You can sell it to the restaurant, too. The restaurant would love the idea of being able to suck people into their restaurant from the area around them without them having to do anything at all. You can market this service to travel companies, Expedia, Hotels.com, whomever, theaters, hotels. They'd all love this service. The other thing that I was thinking as I heard that was how difficult it would be to make that service work. Because just think of what is required to make that worthwhile to Julie, the end user. If she received the text message 15 minutes earlier when the show's still going on, well, that's an interruption. It's an annoyance to her and the people around her if she happens to not have her phone muted. If she received the text message 15 minutes later, when she and her husband are already in the cab on their way back to the hotel, then that's an annoyance. I would have loved to have had this information 10 minutes ago. It's too late now. This illustrates several qualities of information as opposed to data. Useful information that helps you as you go through your day, it arrives in the right place, at the right time, in the right format for you to consume it. And it has to be directed to the right person. Think of all the facts that have to come together to make this work. Somehow, they have to know that Julie was in New York, that she was attending the show, that there was a restaurant around the corner that had a sale. And they had to send that message at the correct time. Unless all of that can happen, it's not information, it's actually spam, which we have lots and lots of spam in our lives. We're drowning in a sea of data. But data, without context, without all of the qualities that make it information, is just spam. data versus information. I hear a lot of people talk about big data and how the quantity of data is increasing in our world, which is certainly true. I don't necessarily think that's a good thing, because sorting through all of that data to find the information you need is a little like digging through a garbage dump looking for nuggets of gold. We need more information. We don't need more data. So now we come to data quality. The thing that will allow you to transform your data into information is these qualities, these dimensions of data quality. And you can Google this. Some sites list 8 dimensions, 6 dimensions. They're all pretty much along these lines here, though. So duplication, having a meaningful primary key on your data tables, this is something that I struggle with a lot in my work. Usually when I'm working through a project and I'm trying to process data so that it can be used in a report or a cube, the first thing I have to deal with is eliminating duplicate records. Either records that have been entered multiple times or possibly just a bad join. Data integrity, having foreign keys on your tables. Conformity, formatting, various check constraints to ensure that the data conforms to the business rules. Completeness of data. Empty columns that aren't supposed to be empty. Missing records. Lost records. And here I will mention a data structure that we'll talk about more later, key-value pair, sometimes also called entity attribute values. The idea being that you have a table and you just have a couple of fields. You have one field that is a key ID or an entity ID that tells you what the record is, and then you have the value. This is a terrific structure that application developers love very, very much because it's very flexible. It's very easy to add new data fields to your application without having to go through all of the design process that you would normally have to go through with a normalized database. And it's very easy to insert data into that structure. Unfortunately, it's very hard to get that data back out. And I often find that you may have data in that table, but you're just not able to find it. And not to mention that performance on such structure as they get large is very bad. Data consistency. We always want to get away from manual checks of the data. We want to automate that to the greatest degree possible. And finally, accuracy, because you can have the data can abide by all of the other 5 dimensions and yet still be wrong. And everybody has to cooperate on that dimension. So, according to a survey by Gartner several years ago, the average data quality runs somewhere between 75% and 90%. That means that in any given data record, between 10% and 25% have some flaw. They violate one of the 6 dimensions of data quality. There's no referential integrity, or the formatting is inconsistent, or there's an error, or some bit of data is missing. And this is all data, whether it's corporate data, government data, medical data. So the cost, and here we come, I think, to the heart of the matter, the cost of working with bad data. Gartner's done other surveys, and on average, as a round figure, the idea is that a data record that is inaccurate or has some flaw in it so that it can't be consumed automatically, it costs 10 times as much to work with that data record as it does a record that conforms in all ways to the ideal. So the implication of this, just running some numbers here, let's say that we have a business process that requires 12 data records to complete. This could be a supply chain. It could be an order process. It could be an insurance collection process. If all of those 12 data records are correct in all dimensions, they're complete, they're consistent, the formatting is correct, so that the machine processes can use it without any intervention whatsoever, each of those operations will cost $1 to complete, just to make it a round number. 100 operations would then have an ideal cost of $100. So the implication of a 25% error rate in your data is that your cost is multiplied by as much as 10 times, because you have to take that 0.75 number and raise it to the 12th power. The odds that all 12 records are going to be complete is around 3%. If your data accuracy rate is 90%, it's actually not much better. You're spending 7.5 times as much as you could be spending. The potential cost savings here is huge. In the same article, Gardner referenced that most businesses can improve their data quality by between 90% and 99%. That's not easy to do, but by continuous attention to continuous improvement, most businesses can achieve this kind of improvement. And the implication of that kind of improvement is laid out here. If you have a 25% data error rate, and you can improve that by 90%, bringing your data quality rate up to 97.5%, then you can reduce your operating costs by 65%. If you can improve your data quality rate by 99%, you can improve your operating costs, you can reduce your operating costs by 88%. The point I'd like to make here is not so much, well, let me take a step back. In America, I think businesses are too focused on numbers. And so you show something like this to an accountant or a financial executive, then they want you to prove it, basically. Show us how we're going to how we're going to improve the data, how much it's going to cost us to improve the data, and then we'll analyze the benefits that we can get from improving that data. I want to point out that this is simply the most easily quantified benefit of improving data quality. There are all kinds of benefits that you get from improving data quality that are much more difficult to quantify, which we'll talk about in a little bit. But even here, there are many things that are either unknown in this equation and possibly unknowable. In short, if I could figure out which records in my data warehouse were incorrect and count them, they wouldn't be incorrect anymore because I would fix them. Just measuring your data quality is very, very, very difficult, let alone improving it. We'll go on. So there is an old saying in Detroit, Michigan, among the big three auto manufacturers, that quality control problems, manufacturing problems, maintenance problems, all start out as design problems. And this is my experience with data as well. If you find yourself writing a lot of very awkward SQL code, you are probably working with a poor database design. If you find yourself struggling with performance problems in your data applications or your reports, this is probably originating as a design problem in your data. A proper database design makes it much easier to record the data in a way that is correct and consistent. And it constrains you to have the proper relationships between all of your different pieces of data. The beginning of a proper database design is your data model. Now, data modeling gets kind of a bad rap, I think. We have some people who are absolute purists, and we've all seen the diagrams with lots of little boxes and lines between those boxes. And occasionally, very occasionally, you will see a database design that requires 50 joins to return the information that you want, which is, obviously difficult to work with. But data models don't have to be that complicated. And in fact, I think the biggest benefit you get from data models is just working with the first one, the conceptual data model. And the conceptual data model is very simple. No lines, no boxes. It's just a definition, a clear, consistent, and precise definition of all of your business terms. Now that sounds easy. It actually takes a lot of work to do in the process to make that happen. I was once part of an effort to go through all of our business terms in my current company. We had to get about a dozen people together on a regular basis from all of the different departments in the company. And then we had to go through each term and discuss exactly what it meant. What we found was there were a lot of conflicts in the definitions that different groups were using. Just something as simple as enrollment can be, just defining that could be a very contentious issue. One group might use it one way. Another group might use it a different way. And usage within the group is consistent, but when the two groups are talking to each other, they think they understand what the other groups are saying, but they're not really talking the same language. It took us 2 years to complete that project. It's very difficult, but the benefit of ensuring that everybody in the company is using the same words in the same way is huge. One company estimated that they saved 50% in their operating costs just by making sure that they were communicating in a consistent way with each other. Here is another issue that comes up often in working with application developers. And I think agile development gets a bad rap as well because many people, many application developers, get so wrapped up in the process of agile development, whether it's Scrum or extreme programming or what have you. They get wrapped up in the process of the sprints and the sprint planning meetings and et cetera, the daily stand-up meetings, all of that. But if you read the Agile Manifesto that was originally published 10 or 15 years ago now, it's very simple and very profound. It starts off by saying, we value people over process. We value working software over useless documentation, things like that. Anyway, two of the core concepts of agile development is that you need to carefully define what the product is that you're creating and who your customer is. And you need to make sure that when you're doing agile development, that all of your customers, all of your stakeholders have a seat at the table and that their input is heard and taken into account. So how does this apply to application developers and data quality? Well, let's take the example of a web development team. You have a web development team, they're creating a website for your company. In their minds, most likely, the product that they're creating is the website. And the customer, what they're thinking about, is the user on the other end of the browser using that website. They're focused on the functionality. Not to say that that isn't important, but as we were discussing earlier, there are actually a lot of other stakeholders in this application. One of the, I think, the most important product of that website is the data that it generates. Unless this is some kind of an online game website, unless it's something trivial like that, the most important product is the data that is coming across on that website. And so who are the consumers of that data? Well, it's everybody in your company. Are you taking sales orders? Well, the order processing team, they're one of your customers. The client service managers, they're some of your customers as well. The people in the data warehouse team who are consuming and aggregating your data, they're customers too, as are all of the business users viewing the reports that are created by the data warehouse team. All of these people are customers of this website. When you're developing the website, you need to keep all of their needs in mind, and they all need to have input into how that website works. My experience is Our web development team, they produce great websites that have excellent functionality and provide an excellent user experience. And but they're very awkward for everybody else in the company because the needs of the other customers weren't kept in mind during the development process. So quality control, well, and so I've written here the first step is measurement, but I just said before that measurement is very, very difficult. And that's true. And here I'm thinking more of a soft measurement. Let's say a measurement of pain. How much inconvenience is created among the various departments in the company by data quality issues? Dr. Redman, Dr. Data, in his presentation, he made this great illustration. Consider some business process within your company. It could be a supply chain management. It could be order processing. It could be processing insurance claims. Now, think of the life cycle of that process. Everybody who has some part in managing that process and the data that's created as a part of that process and how it changes and is updated and evolves as it works its way through that process. And then where it goes after the process is done. It goes into the data warehouse, is aggregated into a cube, and finally gets archived off. Think of the life cycle of that data. Now think of everybody that had any input into that data, touched it, moved it, whatever. Those are the people who need to be involved in improving the quality of that data. That's a large group of people. That's why management is the key to making this happen. And a terrific practice from manufacturing is quality circles. The idea being you take people from all of the different areas of the company, whether they're on the assembly line or they're in the front office or wherever, and you bring representatives from all of those groups together, and they talk about the problems that they have in going through their daily work. And then they start talking about problems that need to be fixed, pain points that could make everybody's life easier, and management fixes them. As an example, in our company, we found the service delivery department at our call center. They had this massive call inventory report that they needed to use. Somebody was spending 4 hours a day going through that report. Nobody in the data warehouse department had any idea. The people in service delivery simply thought, well, you know, that's the job. That's the way things work, you know. We just deal with it. When the reporting team found out about it, they said, oh, wow, well, what can we do? How can we fix this? Surely we can change the format or something and make this easier to use. Just communicating the problems that the different groups have, other groups may see a way that they can help. It's a way of coming together as a team and approaching the problem in a holistic way. So to wrap up here, so that we have time for some questions. point is, I think history is about to repeat itself. In the 60s and the 70s, there was a revolution in manufacturing quality. Companies that had been on top of the world in 1960, by the mid-70s they were struggling, and other companies had come from nowhere to dominate the world markets. I think something similar is in the process of happening with data quality. The companies that can master their data, master the problems, and embark on a process of continuous improvement, they will find themselves in a commanding position within their market, whatever that is. The companies that can't do that, or that don't do that, or decide too late that they'll start to do that, they will just slowly, gradually sink beneath the waves. So here's some further reading that I'd like to recommend to everyone. Dr. Redmond's book, Data Driven, phenomenal book. And then Data Modeling for the Business is a very easy introduction to conceptual modeling. It walks you through the whole process step by step. I highly recommend both of these books. Thank you very much.
All right. If anyone has any questions, feel free to put them in the question panel. Like, we can get David to answer them.
I think Neil is possibly trying to ask a question, but I can't understand what he's saying.
Maybe his microphone is unmuted, probably. Let me see if I can. Is there any other one thing I can ask for the attendees is there any kind of a tool that you recommend or you have seen which can be used for data quality, some kind of a data quality perspective to see what kind of data we have and things like that in the company?
Well, there are not really. There are starting to come out some tools that might help somewhat. Master data management is one of them. The nice thing about that is that comes included with SQL Server.
Mm-hmm.
And basically it is a tool for going through your master data, the nouns in your business process, as it were, and ensuring that the data is consistent and cleaning it up. There are two big problems with this. First, you're cleaning up the data after it's been entered. We really need to get ahead of the process and fix the data, correct the data before it's entered.
Yeah.
Yes. And the second thing is that this obviously is not dealing with transactional data. You can't keep up with transactional data and clean it up afterwards.
Okay. All right. Thank you. Anybody else has any questions? So far, I don't see any questions. So I guess probably everybody's good. And so thank you very much for attending. And thanks, David, for giving us such a great presentation. It's very helpful. I think people will start thinking about data quality as a enterprise wide concern that they can address everywhere. So Thank you very much. Appreciate your talk today.
Thank you.
All right. So
So how do I, oh, let's see. Okay.
right.
And
Yeah.
there we go.
All right. I guess we don't have any more questions. And we will have the recording and the slides posted on our website, and we should be good to go. All right. Okay. Thank you, David.
Thank you.